Here we go. This is 21 and 22. Okay, so you got a limit here. So you're going to plug in 1, piece of cake. 1 over the natural log of 1 you need to know is 0. Okay, now at this point, when you plug it in, you might say, oh, great, this is a L'Hopital's rule situation. That's actually not true. This is an infinity situation. So the limit doesn't exist. It's infinity. And that's just it. That's just the answer. That was very unsatisfying. Okay. 22. What are all values of x for which this function is increasing? Okay. You should know the steps, right? We want to know when a function is increasing. We need to know when its derivative is positive. Let's find its derivative. This is a product rule situation first. Okay, so the derivative of the first function is 2x times the plain old second, which is e to the negative x, plus the plain old first, times the derivative of the second, and this looks to be getting blurry, and I'm dropping it. Come on, get less blurry. Okay, good. Times the derivative of the second, be careful here, it's e to the negative x times negative 1. Okay, so I'm going to clean this up. 2x e to the negative x. I'm going to bring this negative sign in front, minus x squared minus 3 times e to the negative x, like that. Okay, I'm going to factor out e to the negative x because why not? 2x minus x squared plus 3. Okay, this is the derivative. I want to know when it's positive. So I'm going to find its zeros. I'm going to do a little bit of semi-fancy algebra. I'm going to factor a negative sign out, okay? And I'm going to get this. And if this doesn't make sense, pause it, watch, see if you can recreate what I'm doing. X squared minus 2x minus 3, okay? Why am I doing that? Look. Negative e to the negative x. Now I can factor this trinomial. This becomes x minus 3 times x plus 1. I want to know when it's 0, right? So it's when x equals 3 or x equals negative 1. Okay, so that's when the derivative is 0. So now let's come over here and say, make ourselves a little chart. Here's negative 1, here's 3. Those are the two zeros. So now this is the first derivative. You can plug it into any of the first derivatives. That's probably the easiest. So I'm going to plug some stuff in. So if I plug in negative 2, remember, e to anything is positive. Negative of that is going to be negative. So this is negative no matter what. Now let's plug in negative 2. Okay, so this is negative times negative times negative. So that's negative. Let's plug in 0. Negative times negative times positive. That's positive. Let's plug in 5. Negative times positive times positive. That's negative. So this shows us when the derivative is negative or positive. We want to know when the function is increasing, so we want to know when the derivative is positive. That's between negative 1 and 3. Negative 1 and 3, boom, there it is. D, you're done.